I know there's a lot of crazy rush going on right now to get the work done before the end of the year. So thank you for joining us. I'm just going to share my screen quickly and we can get going. I'm going to screen share and we can go. Righty, let me go straight into SOLIDWORKS. So right, for those of you who don't know me, my name is Quinton Berger. I'm the Chief Marketing Officer here at MiCAD. I really enjoy SOLIDWORKS. It's been one of my babies for the last 17 years, along with the other many babies that I do have in real life. But this is a really exciting webinar. This is something that is near and dear and close to me, and we hear a lot of questions about performance, especially with the fact that SOLIDWORKS 2021 has a lot of performance enhancing features. We decided to do a webinar not only on SOLIDWORKS 2021 features, but just general performance features in SOLIDWORKS and tips and tricks. And we're going to go through some really interesting stuff today. So thank you for joining us. So just a quick agenda. I'm starting at 1 o'clock on the dot because there's a lot to get through in the next hour with you guys. So what we're going to do first up is talk about drawing performance tools, which I'm going to do as well as the performance pipeline. I'm going to talk a little bit about the back end stuff, some really interesting background information as to how SOLIDWORKS and your graphics card and your PC actually works. There's been a lot of questions around graphics cards and CPUs, and I want to give you some little bit of, I want to geek out and nerd out and show you some really cool things, how SOLIDWORKS actually understands that. Then we're going to have a quick 5-minute chat to Pierre Frangi on our PDM team. Here at MiCAD, we're going to try and get him on board for 5 minutes, which we'll talk a little bit about that. So then we're going to hand over to Kieran Barnard in our Durban office, and we're going to talk about SOLIDWORKS tips and tricks in large assemblies. So we'll also have some time for Q&A. So just a big thank you to all of you who attended our launch last month. It was a lot of fun. We gave out thousands of rands worth of Uber Eats vouchers. We gave away a drone to the guys at Saab, and we really had a fun time with this webinar. And if you have not seen the webinars, there were 3 days we did it over, and you're more than welcome to go to our website micad.co.za and have a look at the recordings. All the recordings from the 3 days are there, as well as the 3 guest interviews we had, which was really interesting as well. So go and have a look at our website for more information. We also have a series of SOLIDWORKS promotions. It's Black Friday everywhere, and I decided not to call this Black Friday because it gets a bit corny. But we really have some amazing SOLIDWORKS promos on at the moment. So if you are interested, look at our website for more info and contact us. We really want to engage with you guys. So let me move away from PowerPoint into SOLIDWORKS, and I want to jump straight ahead into drawings, tips, and tricks. So, by the way, this session is recorded, and we will put it on YouTube and let you guys have access to the files. About a half an hour into the webinar, we are going to post the PDFs of the PowerPoint presentations that we have done today, so you can grab them there as well. There will be a handout, so have a look in the side of the interface. And then go ahead, while we're here today, please go ahead and use the chat on the side. It's already active, so if you've got questions, I've got my team looking out. They can help. And they can jump on board and ask me questions a little bit later on. So please go ahead and use the chat. It's a big marker. It's quite a fun, interactive interface, and we had fun with it at our launch. So please don't feel shy to ask questions. So I'm going to start off with drawings. So the first thing I'm going to do is go into SOLIDWORKS, and I am going to demo live. I like working like this. I just want to show you how fast this really is instead of me speeding up a video. So what happens sometimes, or most times, when we're doing some detailing work with drawings, we need to go in and out of drawings, switching between drawings, and you end up loading a lot of drawings on your PC, and it slows things down. So we end up closing down all the models and reopening things, and this causes a problem, especially if I want to measure a dimension or just add a detailed view. And about 2 years ago, SOLIDWORKS came up with a detailing mode in SOLIDWORKS drawing. So if you're going to open a drawing, go and have a look at this little slide over here. The quick view will just open up the drawing immediately in a view where you can print and save. But detailing mode actually allows you to detail and work with the drawings. But look how fast this is. This is about a 2,000 or 3,000 component assembly. It's pretty large. And when it opens up, it asks me, do I want to resolve everything or do I want to work in detailing mode? I say, no, continue detailing mode, and it's like 3 or 4 seconds, immediately opens up the assembly. So 2 things. There's a graphics side, which is working from my graphics card. That is the visuals, as I'll explain a bit later. What this is a completely different technology altogether. It's got nothing to do with our graphics cards. This has got to do with SolidWorks. Now, sorry, let me just check. Can you guys all hear me still? Just want to check. Kieran says I got no sound, but I'm pretty sure that my mic's on. Yeah. So what I want to show you is that even though I've opened this thing in a detailing mode, I can still do things like detail views. I can add broken views. I can do crop views. And you'll see all of these buttons at the bottom here, all of these sheets are actually then loaded. And look how fast it is for me to switch between sheets. So although I've got this 3000 component assembly not loaded, I can see all of it as if it was just a 2D graphic. But it's a little bit more than that, because I can actually go ahead and do things like a broken view. Now, I'm not going to spend too much time. More than welcome to go look at the webinar that we did and I'm going into detail on all these different tools. But it is really, really functional and excellent. You know, if we go look at this plate at the bottom of here, you know, even though it's in a detailing mode, I don't need to load the actual model in this. There's no need for that. I just want to do some quick detailing mode. I want to just do some detail on the dimensions, hole call outs, notes, spelling checkers, you know, all those kinds of things. You know, basic detailing work, and I think it's a really, really handy tool. And the feedback from the users has been excellent with this tool already. So I really wanted to highlight this to you guys. Just want to make sure that everything's okay. Yeah. So what I wanted to also show you is the speed at which SolidWorks 2020 and 2021 specifically, how fast the graphics is as well. So not only does it load fast, and you've got the ability to resolve the assemblies as well after, but just have a look how fast it is in using the new SolidWorks 2021. They've really improved the way the graphics, you know, how the graphics card works with your modeling. So as soon as you pan, zoom, you don't have that blocky effect that used to hang around as long. It's really, really snappy and quick. So SolidWorks has been working on this over the last 2-3 years, and 2021 is the manifestation of all of this. So what's great about this is that if someone else in my engineering team opens up this assembly and changes it, SolidWorks will still know, even though it's not fully loaded, it will notify me that it's updated, and it will actually make it like it'll make like a red mesh over the model telling me that it's been updated and I need to actually load my model. And you can resolve it on the top right-hand corner. So a little handy trick, go ahead and use detailing mode, super good, a really, really handy tool for doing detailing work. Now I'm going to switch all the way across into PowerPoint and go and have a look at this little PowerPoint. So bear with me, I'm doing a lot of PowerPoint, but I'm going to give you a little bit of an IT computer science lesson here, which I found very, very interesting. So I'm going to try not to bore you, but I'm going to make it as interesting as possible. So one thing, keep in mind that no matter how fast or how current or how expensive your workstation is, it's got a finite amount of instructions per second that it can perform. And we've had a lot of customers over the years go ahead and buy these, you know, very expensive custom bespoke PCs at ridiculous amounts of money because their SolidWorks is slow. Remember that there's only a limit again to how many calculations or instructions it can do. So the problem as well is that if you don't take care of your modeling techniques, it doesn't matter how big your PC is, eventually it will get slow again. So you've got to work with having new hardware and techniques, and we're going to go through a bit of both today. So if you look at this Intel, for example, it's Intel's got these strange names: Coffee Lake, Intel CPU. It's got 35,000 million instructions per second. It's 35 billion instructions per second. It's kind of mind-blowing how fast these processors are. But then moving to the graphics card, this is NVIDIA Quadro. It's about a K2000, K2200. It's a normal mid-range engineering graphics card. And this works a little bit differently. So these are capable of displaying those filled triangles per second, because remember that SolidWorks works with tessellated information, which I'm going to show you now, little triangles. So remember the 190 million filled triangles per second. That's when you're rotating things around. That's what it's capable of doing, 190 million. So to understand how to fix your SolidWorks assemblies and drawings, we first need to understand how your computer actually produces these images. So there's actually 3 very interesting steps that SolidWorks goes through in order to show you the model that you see. So you've got a tessellation step, a Z clipping step, and an HLR step. So I'm going to go into a little bit of detail now, showing you what this actually means. So there's a bit of simplification tool around the graphics pipeline, but most 3D programs actually use this graphics pipeline, as I've just said. There's normal CAD, like what we in the industry in general CAD. You've got the gaming, like Fortnite and Call of Duty. You've got AR, VR headsets with HTC Vive. They're all using that exact same graphics pipeline: tessellation, Z clipping, and HLR. So step number one is tessellation. Let's go and have a look at what tessellation is. So your object looks like that in real life, but actually it's not really a full B-rep model. It's a little trick called tessellation. So your actual cylinder that you draw in SOLIDWORKS is made up of thousands or hundreds, or sometimes hundreds of thousands of little triangles put together. And your graphics card then shades and smooths that over so that it looks nice and round, like the one on the right-hand side. So let's have a look at triangles, tessellations. That small cylinder that I just showed you, as default SOLIDWORKS settings, has got 164 triangles in it at a default. So just keep that number in your mind, 164 triangles. And I've shown you, most of you, this before, but if you go to the document properties inside of SOLIDWORKS, there's a little bar that you can move, slider bar left and right, which allows you to have faster or slower in SOLIDWORKS, which means number of tessellations higher or lower. So be very, very careful not to push that slider all the way to the right. Otherwise, you're going to have an incredible amount of triangles. And I'm going to show you a few examples of that a bit later. So that's under document property, image quality. Keep it in the middle and to the left. I'm sure all of you have seen this, where you're working inside of SOLIDWORKS and you've got a large assembly and you click on a face, you say in context, and you draw a circle. And your sketch is perfectly round, but the hole that you've drawn over is hexagonal. And that's just proof that SOLIDWORKS breaks up those models into triangles, that tessellation. So that's just a bit of understanding of what's actually going on. Why does it look like a hexagon although it's a circle? It's because of that tessellation effect I've just explained to you. So remember the 190 million triangles per second? So remember the small cylinder. If I put that cylinder in an assembly, because of the maths of 190 million, so if I just did a reverse mathematics, I'd be able to take that cylinder and do a pattern of that to have it over 1 million instances, because my graphics card would be able to rotate that around. Simple maths. And by the way, SOLIDWORKS can open up 1 million components in an assembly. There's a few chats on the SOLIDWORKS forums about how many millions of parts you can actually open. Whether you can rotate it or not, that's what we're going to discover now. So, well, why does my SOLIDWORKS still take so long to open up 3D? I don't have anywhere near 1 million parts in my assembly. And it's still choppy when I rotate it around. And let's go and have a look at a simple illustration. And this is going to give you a very good understanding of why and how it gets to the point where it becomes very difficult for your graphics card to move around. So all I've done to the cylinder is add 2 little fillets and stick text on the top. So this is test text, and I push save. Now, there's a 2,859% growth in the number of triangles in the assembly. So all of a sudden, I went from having a possibility of over 1 million parts in my assembly down to 39,000, just by doing 2 fillets and text, because it's got to fill in the triangles for all of those added bits of geometry that I've just done. So be conscientious in what you put into your assembly. Please, for the love of all that is good, do not take things like bolts and nuts and extrude text in there, because I've heard this a number of times. Yeah, but it looks great, or I need it for ordering. No, you really don't. There are many ways and techniques that you can get around doing that. By having something like Acme cursive writing onto the nuts and just doing an extrusion cut adds so many hundreds or thousands of triangles to your model and slows down your whole assembly. Imagine having 300 or 400 of these nuts in your assembly. It's pretty mind-blowing. Please note that any helical shape like this is the worst of the worst for creating triangles in your model. And if you think about any helical work like this, this is exactly the problem with doing bolts. So if I've got a bolt or a nut with the helix cut into it, again, have 300 or 400 over these, you're adding millions and millions of triangles to your assembly, unnecessarily. Then the next step in the performance pipeline is this Z clipping. So pretty easy, guys. This is just a simple definition. It's deciding which polygons are visible to the viewer at the direction of the view. So if I just rotate that and look at it from the front, it's a little a truck in front of a house, and it's just going to look at it from the front view. So that is a B-rep broken down into triangles because I'm looking at it from the front, and your computer must decide. And I'm going to do a very nice illustration with my mug in a second. So these triangles are taken care of with a Z-clipping algorithm. So others are only partially included, and they need an HLR calculation to be done in order to understand which portion is visible from that angle and which is not. And this is a really complex calculation because it's got to see what's not seen. Okay. So I'm going to show you my mug. So I'm just going to do this for a second. I'm going to stop sharing my screen so that you can see me. And I'm going to just show you my mug. So I'm going to have my daughter's book. Graphics card still is trying to look as you rotate that model. Can I see it? Can I see it? No, I can't. No, I can't. Can I see it? No, it can't. It's still deciding whether it should show it or not show it. So it's always doing mathematics to release and calculate whether it should show it or not. Very, very interesting. How does this pipeline come into effect? So you can actually turn it on by default in SOLIDWORKS 2021. It's on by itself. And in 2020 and 2019, it is there as an option for you to turn on in beta. But in 2021, it was completely released. So what that work I've just shown you now, I've told you, the graphics cards have become very, very good at doing that pipeline I've just told. And in fact, I just told you about. And in fact, the newer graphics cards use things like machine learning and artificial intelligence in order to predict what it's going to be. So the performance is incredible. By having that little tick box on, it allows the graphics cards to use all that artificial intelligence and machine learning in order to unlock that speed. So here's an example of a SOLIDWORKS model going through a macro. It's gone through a number of rotations with that tick enabled and with that tick unenabled, unticked or unselected. And you can see that it's 7.9 seconds versus 160 seconds to rotate and zoom and move around. So the instructions done with the macro were done at 63 frames a second, while the traditional method was in 3 frames a second. It's a huge difference. So by having certified graphics cards in the latest versions of SOLIDWORKS will completely change the way that you work, and that's going to be in parts, assemblies, and in drawings. And you're more than welcome to trial this and speak to us. If you've got an older version of SOLIDWORKS, come speak to us, and we are very happy to trial it with you. Now have a look at hidden lines visible as well. It's incredibly fast. So it's just a different way of working completely. This graphics occlusion as well. You will see that the SOLIDWORKS 2021 will actually remove, as you rotate the model, actually remove some of the graphics from behind the model. That's unnecessary. So we just added a feature that allows us to show that. It was really interesting, actually. Very clever techniques. All right. So I've really tried to run through that as quick as possible. I've just done the science of how SOLIDWORKS thinks, and I really enjoyed doing things like that. It just gives you an understanding of what does this pipeline button mean? What is it for? And that puts it all into perspective. So I really hope by showing you and explaining to you the back end of how things work, that as we go on for the next 40 minutes, the techniques and things we're going to show you is going to have a little bit of context. So I've done a bit of drawings, I've done a bit of a performance pipeline, and now I want to speak a little bit about PDM. PDM is a tool that a lot of you have with SOLIDWORKS Pro and Premium. And I just want to grab Pierre quickly. Let me see if I can grab Pierre. I hope his, just give me 1 second. Are you okay, Pierre? Okay. All right, just give me a second, guys. I just want to get Pierre on board. Right, I found him. Make presenter. I'm just going to put him on stage quickly. Bring on stage. Pierre, can you hear me? He's probably just logging on for a second. There we go. You just muted, Pierre.
Is on my side.
There we go, I got you.
There we go.
So I'm just going to share my screen again, and then we can talk a few seconds. Maybe just introduce yourself to the audience quickly, and I will share this.
Hi everyone, my name is Pierre Francie. You'll actually see that it says there on the screen I'm Arnu. That's my second name. So for some of you, I'm Pierre. For others, I'm Arnu. I'm the professional services manager here at MeCAD, especially for PDM as well, focusing on the PDM side, and then as well as with all of the collaboration and consultations, implementation, everything like that. So if you need any assistance with that, you can just contact me, and I'll liaise with my team to get in contact with everyone else.
So I really wanted to bring Pierre on quickly just to have a chat with him about performance in PDM, because we've had a number of customers that have struggled with saving files over the network. When they save files, open files over the network, it becomes really slow, and we get these calls, and PDM solves a number of that. So maybe Pierre, if you want to just talk a little bit around those 3 points quickly in 5 minutes around collaboration, file saving of the network, and the backups. Let's just have a quick chat about that.
Yes. So if I can start off with a very important thing about PDM, it is on a server base, but all of the files is actually locally. So an important thing with a local file is that that file is actually cached onto your machine. So there's no copying of files from the server to the client side, and then there can be intermittent network issues or anything like that. So a very important thing for PDM is that because I have the files locally, if I save the file, it saves to my hard drive, or like you mentioned, onto the SSD drive. That's actually even quicker. So only when I check the file back into the system, then it will push the file over the network to the server location where actually all our backups are going to go in. So that's also very important because we need those backups for if anything maybe goes wrong. And luckily with PDM, it'll just do the implementations of the parts. So we'll always have those versions. So if anything ever fails, we could just go roll back in one version. We have that full history list on that. So that's a really good thing for PDM. Especially now in 2021, the performance has been drastically increased. So with the performance benchmarks that we've been busy testing, we've actually seen almost like 1.5 to 2 times quicker response times with, let's say, for example, your change state or your check-in of files, and even opening and saving of the file. So that's a really important thing for us engineers, because like the old saying is like, work smarter, not harder. PDM just ensures that we can actually work smarter and faster. Even small things like shortcuts. So in PDM 2021, you can now just do a Control-I to check in files, Control-T to do a state change. Even those small things, incrementally, if you do it over 1,000 times in a day, you can make yourself an extra cup or two of coffee without having to wait on your manager for certain information. So that's a really, really important thing for us working with the PDM side is, again, ensuring that the files are local and not copied to the server like most companies actually do. And then they struggle with corrupt files if the network dips or anything like that.
Something I found interesting as well, Piers, that if you go to 1,000 component assembly and you working on that assembly, you only change 3 or 4 parts of that 1,000 component assembly. When you actually save the file or check the file in, it only checks the file into the server of the 3 parts that changed. Because if you've got the files saved from the server or open from the server and you click save and you only change 3 parts, it's actually going to save all 1,000 of them over the network. So if you've got 3 or 4, 5 guys in your team working over the network, there's a massive amount of network traffic happening there, as guys are saving files and opening files. So there's a bit of intelligence that goes with that as well.
That is very true, yeah. And it also, because I'm caching the file onto my machine, even if I go and get that assembly again, it'll actually first go and look on my cache memory to see, okay, but that file version is already on my machine. There's no need to copy that part over again to my machine. So even if there was only one that changed, on a normal network system, you will copy that entire bundle over to the server and copy the entire bundle back. PDM will just ensure, okay, only one file updated, just pull that one file. It's just so much quicker to use it then.
Yeah, no, brilliant. And again, thank you, Pierre.
Pleasure.
If you are a single user, because we've had that conversation as well, and I only have a pro seat of SolidWorks, use PDM. I promise you, it is gonna save your life. So even if you got if you're one guy and you one person in the team or 2 people, use the PDM standard that's available to you. And if you want help with that, contact us and we can give you a hand. Thank you, Pierre. I am gonna just stop sharing for a second, and I'm gonna just launch a few polls. I'm just gonna pause here quickly for a second and run a poll. So thank you, Pierre. We will chat to you again. Polls. So give me a second. I should have a break here because we're about halfway, and then I'm going to hand over to Kieran. Just going to launch a few polls quickly. So just a question on the graphics cards. Is your graphics card older than 4 years? I just want to gauge, because remember what I said, in order to take advantage of that performance pipeline, your graphics card needs to be newer than 4 years. It would be interesting to hear and see how many people are having an older or newer graphics card. All right, very interesting. It's about half of the people in the group have newer graphics cards, and the other half, which is about 40% of people, have graphics cards older than 4 years. If your graphics card is older than 4 years, come to me and we will help you prove that the newer graphics cards can unlock a world of difference for you. So If you need justification to management in your company why you need to upgrade a graphics card, speak to us and we can help, because the performance is quite staggering. The difference is huge. The next question I've got is a question around your readiness for holiday. Are you on a scale of 1 to 100? How ready are you, or how done are you with 2020 and ready for your holiday? I'm going to the Wild Coast. I'm going to kick off my shoes and go and sit on the beach, far away from any virus. I think it's been a year to forget for everyone, but it's good to be at this time of year. The festive season is great. So yeah, overwhelming response. Everyone is very pumped for holiday. Then the last one quickly is just the discussion around PDM. If you need PDM, if you need advice on PDM, or if you need for us to point you to some online training, or if you want some more information around the how to set stuff up, let us know. And I'm more than willing to send some stuff to you guys to give you some advice around PDM. All right, I'm going to close the polls, and I have just given some handouts as well. So have a look at the handouts. These are some of the presentations. I'm going to now hand over to Kieran. I think that's everything from my side. Kieran, I'm going to just hand over to you. Kieran, can you put on your camera and mic, and I can hand over to you, and you can share your screen, and we're going to move on to part 2. There we go. I can hear you. Oh yeah, you must just start sharing your screen. I'm going to turn my camera off.
Sure. Okay. Welcome, ladies and gentlemen. And in this webinar, I'm going to actually take you through large assembly performance. So let's go ahead. Next, I'm going to look at what constitutes large assemblies. So is it something like 1,000 parts, 5,000 parts? Is it determined by file size, 100 megs, 500 megs, a gig? Well, no. A large assembly is an assembly that uses most of your system resources and significantly slows down your work process or your workflow. So this is often, slow opening times, slow rebuilding times, problems with rotating and stuff like that. Okay, so without further ado, let's carry on. Next, I want to take you through the file opening process. So as you can see, when you actually go and scroll in your Windows Explorer, click Open Assembly, what it first does is it locates and loads component files into RAM. So this is why it's important to have a minimum of like 16 gig RAM is what we recommend. But if you're working with very, very large assemblies, we do recommend a bit more. So it is worth it getting more RAM. Then from there, you'll see what it does. Then it looks and says, are there any changes since I saved or since the file was saved? If it's no, then what happens is it runs through the entire process, bypassing this whole section here, computes the tessellation, and then the assembly is open and you can edit it, rotate it, and start working with it. But this is hardly ever the case. If you make changes to any of the components in the assembly, it will then say, okay, are there any changes? Yes. Okay, what do? I update the out-of-date components. So I rebuild them, make the changes, check their space, or, in the XYZ, direction, and actually look, okay, do I need to update the mates? No. Go back to tessellation, you can work the model. Do I need to, if I do update the mates, I update the in context and the assembly feature, so it pushes through those changes. So say now I have references or top level references, then it'll actually change those as well. It then looks and says, okay, has anything moved? Yes. And then it just carries on consistently running through the process. Okay. But, right, if it says something hasn't moved, then it's fine. Compute tessellation, and again open assembly. But in this little loop over here, what I want to show you is this is where you get stuck with opening, where it opens errors, warnings, stuff like that. It can't actually figure out the mate. So what it does is first pass, sends it around. Okay, again, tries to solve the mate, can't fix it out, tries to update it, and keeps on doing that till a certain threshold. And then after that, it will actually open the model. So again, computer tessellation, go through to the model. So that's where it's quite important. So again, I'll stress this again a bit later, but errors and warnings and tessellation data are the biggest performance killers. Okay, So with that in mind, how do I actually improve assembly performance? Well, there's a few little lovely tricks that SolidWorks actually has, or some functionality within SolidWorks, where it actually allows you to open assemblies in lightweight. So before I carry on explaining this, let me just do a little live demo for you here. So within SolidWorks, just get my mouse back. I'm going to then click open. You'll see I'll go to my files. And from here, I'm going to open the telescope. Now, as you can see, there's a little mode slider here. I can then click lightweight. Or if I'm scared that I keep on forgetting or something like that, what I can then do is my system options, assemblies, and actually set a threshold. So for example, the standard threshold is 500 components. So this model should automatically open in lightweight. So I'm going to actually now go and specify lightweight. Remember, it will automatically open it, but I'm going to just double check and make sure that it open in lightweight. You'll now see it's going to open up the components. All right, so it does take a couple of seconds. This is about 5,000 components in this assembly, so you'll see 13 seconds. That is very, very impressive to open about 5,000 components. That's a lot. That's quite good performance. And then also what I want to show you is the little icon over here. So you'll see it looks like a little feather on top of my part. By simply clicking on the drop down, you'll see it's going to carry on and continuously load those. So what we call this is on-demand functionality. So if I go and I'm working and I've got a sub-assembly here and I go and select there and I say, okay, it's this assembly here, for example, you'll see it's continuously loading my selections. Okay, so it makes your life a lot easier. It's a lot faster. It doesn't load everything. It only loads a subset of the metadata, and the rest is loaded on selection of the component. Let me just pop back to my PowerPoint. So you'll see here, like I said, the remaining of the data is loaded on an as-needed basis. There's one thing to note as well, is the larger the assembly, the larger the performance gain. You'll also see if I want to set my entire assembly to resolve and I've opened it in lightweight, you can simply just right click at the top here on your part and say set to resolve to lightweight, or vice versa. You can also do this on a part or sub-assembly level. Okay, next we're going to look at large design review. Large design review is when you are opening huge assemblies. So let me quickly go back. We're going to run through a little live demo again. So now we're actually opening up our full telescope. What I'm going to do is here say large design review, and I'm actually going to click editing. So while I do that, I also just want to show you that if you under the assemblies, you'll see there is also a little threshold here. Okay, I'm going to select it, and you'll see it will also allow it automatically to open these components in that size, or in that above that specific threshold. It will always open it up in the large design review. So from here, again, large design review, I'm going to click edit assembly and select OK. Okay. So what I would like to stress again is this component is about 60,000 parts. It's quite a big assembly. And then I just want to show you, it gives you this lovely little pop-up menu, and it actually just shows you what can you do in large design review. So you'll notice I clicked that edit assembly. What does that edit assembly do? It allows you to open or insert components, delete components, move and rotate components, create, edit, and delete mates. But also, as a standard functionality, it allows you to create walkthroughs, hide and show components, create cross sections, measure distances, select open components, and then you can also look at your design tree and actually just see how the product was designed. So from clicking OK, see, my apologies, I must just unactivate cam. You'll see if you just give us a few seconds, like I mentioned again, guys, 60,000 components, and you'll see there it's loaded. Okay. You'll see while it's just loading the subset of graphics data, because in this form it loads graphics data, you'll see here at the top, insert components, mate, can create some patterns, add a walkthrough, you can actually measure. So this is absolutely wonderful for making changes on a top level, or if you need any reviewing purposes. Again, I can also go select resolve, create, set components to lightweight, so I can always go open in lightweight and stuff like that. It just allows functionality, or it allows a lot smoother working with very large assemblies. Okay. Again, like I mentioned, there is a specific threshold that you can set where it runs through automatically if you don't want to select it each time. All right, then tip 3, let's talk about in-context features. What I'm going to ask you is limit the use of in-context features. In-context features and their child components must be rebuilt when the assembly changes. Okay, they require more resources than bottom-up assembly or bottom-up components. It's just an assembly method or a design methodology. What I advise is enabling suspend automatic rebuild. You can find this under your system options, assemblies, and there's suspend automatic rebuild. What it does is it allows you to make a bunch of changes at once, and every time you actually exit the feature, it doesn't automatically rebuild it. You actually have to go and rebuild it afterwards. What does it do? It stops it from making a change and then rebuilding, then make a change and then rebuilding, where it allows you to make all your changes and then at the end you can rebuild. This does really, really help. It really makes quite a big difference, especially when you're rebuilding large amounts of data. Okay, and then next we're going to look at external references. This is good for the CAD admins. If you guys don't allow any external references as your design methodology in the company, you can actually turn it off. So you can say allow creation. You can actually turn that off, or what you can do is control it to specific levels. Okay. Next, we're going to look at tip 4, so sub-assemblies. You're using sub-assemblies. What does it do? It reduces top-level mates. Placing the majority of mates in sub-assemblies instead of the top-level assembly allows the top-level assembly to solve faster. Why? Top-level assemblies or top-level mates, remember that graph, it's part of that opening process. Okay. If it's a sub-assembly, it automatically assumes it's rigid and doesn't redo those mates each and every single time. Then that brings me on to flexible sub-assembly. So I'm sure many of you have noticed if you click on a part, there's this little icon over here. It's on the right hand side in red. That means make flexible. What does make flexible do? It actually allows you to replicate motion in your assembly. So if you have a sub-assembly and you're trying to drag it and it's not moving, make it flexible. And if the mates allow and you've mated it in the correct way, it will allow movement. But these take more resources. So guys, please focus, or ladies and gentlemen rather, please focus on limiting their usage. Again, if you use them, make it flexible, make the sub-assembly flexible, do the movement, do what you need, do the design, change the things, and then afterwards make it flexible or make it rigid again rather. So you'll see, how do you create it? You just go and simply re-click on that icon. Then we're going to talk about use of component patterns. A lot of people really underestimate this little feature, but patterning, for example, I think I prefer to give examples to actually prove and show you. So you'll see on the image on the left-hand side, what I did was I took an assembly, I added 15 instances, or 50 instances rather, and I mated them exactly in the same way. They're in the same area, same space. Nothing's different. The two files are identical, but one I've used patterning and one I have not used any patterning. So you'll see we have actually used patterning. It creates 7 seconds, so it opens in about 7 seconds. And the one where I've used no pattern, it opens about 20 seconds. So that's quite a big difference, right? So again, patterns save time in editing the parts and assembly levels, and again reducing the number of top level mates required. So quite a big time saver. Next, we're going to talk about using simplified configurations. So as you can see, I have 2 bolts here to the same file. However, one has got the cutout, the recess in the top, and it's actually got the thread, and the other one is just a simple bolt. So this component in this example is actually a buyout. Now, what is the significance of that? You don't need all this complexity of the design. While it does probably look a bit better in your top level, if it's a large assembly, you're also not going to necessarily see this level of detail. So it's not really necessary. So what do we say? Use a simplified configuration, right? So if I can give you a good example here, if you look, the total rebuild time is 1.16 seconds on the left-hand side, and on the right-hand side, it's 0.14 seconds. Why? It's a significant change in amount of time, but 1.16 seconds doesn't sound like a lot, right? I have 1,000 instances of this component, which is not unheard of in large assemblies. And we're talking 20-minute rebuild time just for your bolts. Guys, not necessary. So please use simplified configurations as well. Tip 7 is setting optimization. So I'm going to talk about two main ones for now. As Quentin has mentioned, tessellation. He's done quite an extensive little section on tessellation, explaining the actual implications of using it and what it is. Well, I can just use this as an example here. Please, if you want to change the tessellation, document properties, or system options, document properties, image, and drag these down. This looks like a hexagon, however, it is still a perfect round circle. If I design this component and send it to CNC milling, it will still be a perfectly round circle if I've designed it as a circle. However, my visual representation will be more of a hexagonal shape, or more of a sharper shape rather. I just put this little image here on the right hand side at the top, just as you'll see the M6, so the one I used in the previous example, you'll see M6, it has about 1.8 million graphics triangles, okay? And you'll see there's about 90 of them, so that includes obviously the totality of it. And by simply just actually dropping down the document property for that M6 bolt, I managed to drop it down from about 1.8 million to actually roughly, I think it was about 600,000 or 700,000. So it's more than half. What does this do? It allows us to bring the file size down, overall allowing workability, opening times are faster, and then rebuild times are faster. Remember that workflow I spoke about? Generating graphics is the last section of opening a file. Okay. And then finally, verification of rebuild. Verification on rebuild, what it does is it allows advanced body checking. While this is absolutely wonderful when you're designing, when you are trying to focus on performance and you're actually in an assembly environment, this is actually not that necessary. You don't need it. So just turn it off. Especially if you're designing in sheet metal, this is a brilliant, brilliant feature. But again, top level assembly, there's no need for it. Okay, and then we go to the next slide. So next, we're going to look at tools to evaluate and improve the performance. So SolidWorks has some built-in tools and some features that actually allow us to follow a very nice workflow. And it actually shows us, okay, what is wrong with our assembly? What is taking time? What can we improve on? So from here, you'll see that the assembly progress bar, right? This isn't actually it doesn't have anything to do with improving your performance, but what it allows the user to do is actually see the status of opening the assembly. You'll see a lot of times we do see that, when opening the assembly, you click, nothing happens, the screen just throws SolidWorks, and then people carry on clicking. What it does is it crashes the software. So now with this assembly progress bar, it also just allows you to see, okay, this is what it's doing. It shows you, it's basically a 3-step process, which more or less covers that workflow that I showed you right in the start. So you'll see the final step after it generates the graphics is just to finish opening assembly. Just also a little interesting fact is that window will keep on displaying on your screen if it takes longer than 60 seconds to open. However, if it opens less than 60 seconds or a period shorter than that, it will disappear automatically. Okay, so you'll see now what it does is it also allows you to select performance evaluation. So say now I have assembly that opened in 45 minutes. Let's say one revision ago, it was only opening in 5 minutes. So I can actually have a look, okay, why? What is wrong with it? What's causing those performance issues? And from there, I know what to address. Okay, so let's elaborate a bit more on performance evaluation. So you'll see I have an assembly there that takes about 74 minutes, for example. By actually opening the performance evaluation, so you'll see I've opened it of the telescope itself. It actually shows me certain sections are taking 4.2 seconds, 1.65 seconds, less than 1 second, less than 1 second, which actually shows me the totality of the file open times. Okay, it then also looks at previous versions. So previous versions, what SolidWorks does is if it opens let's say a 2016 file and I'm working in 2021, and the moment I need to make any changes, I actually need to rebuild it and save it out in a new structure or a new format that is 2021. Okay, so it actually shows you in here That can really slow down your workflow, but it only is a process that happened once. So you can actually see if there are any of those components in there. And then as well, it shows you the display performance. It actually gives you an indication of graphics triangles. Okay. Right. And then what it also allows you to do is look at the amount of mates. So again, this is where it shows you the amount of top level mates, and that is, you'll see there it says 70 mates are evaluated when this assembly is rebuilt. So if you have something like 3,000 or 4,000 or 5,000 mates, it has to rebuild each one of those mates every single time you actually rebuild the assembly. So again, that's why we're trying to stress on limit top level mates. Okay. Then assembly visualization. What I just want to show you is over here at the bottom. If you actually click on the performance evaluation window that pops up, there is also an assembly visualization. Assembly visualization actually gives you a color-coded reference and shows you, okay, if I click on this little button here with the robot, it then says, okay, SOLIDWORKS rebuild time, and then it actually shows me in terms of a graphical representation what is taking longest to rebuild and what isn't taking long to rebuild. So you'll see, for example, this component here at the top. Sorry, let me just go back there. You'll see that that one's taking about 2.9 seconds. This model itself is already very optimized, so there's no need for us to optimize it any further. But you'll see sometimes as well, it'll be like 50 minutes or like 1,000 seconds or 2,000 seconds. You know, then if that's the rebuild time, there's something wrong in that model. Okay. It also gives us graphics triangles, so it allows us to go and look at, maybe we need to push down tessellation on those specific parts, and stuff like that. All right, so I just want to show you as well, say now you don't access it through the indicator or the opening indicator progress bar. You actually, already have this model open, and then you realize, I'm not happy with the performance. Well, you can get all that functionality from simply going to your evaluate tab. You can go and look at your performance evaluation over here. You can look at the assembly visualization, and then from there, you can actually look at your rebuild time. There is some other functionality in the assembly visualization. However, it's not performance specific. It's more graph specific or information specific. Also, before I move to the next slide, I just want to show you that the SOLIDWORKS opening times are also here. So as you can see, it's taking less than 0.1 seconds to open most of these parts. So like I said, this actual assembly or sub-assembly rather is highly optimized. Okay. And I'm going to take us to the end of our webinar. So I'd first like to just thank you for your time. And guys, if you need anything, or ladies and gentlemen rather, if you need anything, please feel free to contact us at support@mecad.co.za. You can also ask us questions about large assembly. So you can come to us and say, we have a large assembly that's really slow, and we can actually have a look at it and see, okay, maybe try this, maybe try, have a look at the tessellation, have a look at the structure. Okay, and I thank you so much for your time, and stay tuned